All right, good afternoon. Good afternoon, everybody, and welcome back to another edition. And in fact, it's the 6th episode now of the 3D Friday talk show. I'm Michael Petch, editor-in-chief of 3dprintingindustry.com, and I'd like to thank Free Your Mind and America Makes for organizing today's event and making everything possible. So today's topic is going to be, is 2020 shaping the AM trends of the future? The 3D Friday talk show is an interactive event, and so we're going to be taking questions after each section. So please, if you have questions for our guests, please do write those in the chat function on the right-hand side of the screen. Okay, so joining me today to help answer these questions are two very well-known leaders in additive manufacturing. And now Marie Langer is the CEO of EOS, and Rick Fulop, of course, is the CEO and founder of Desktop Metal. So good afternoon, Marie, and good morning, Rick. Are you there?
Yes, we are.
Hello, good to see you both.
Good to see you.
And happy late Thanksgiving to you, Rick.
Thank you. Thank you. Yeah.
So, Marie, I'm sure very few people will not have heard of EOS, but would you mind just saying a couple of words to introduce yourself, please?
Yes, of course. So, hey, I'm Marie Langer. I'm second generation of the owner family of EOS. My father, Hans Langer, founded EOS 30 years ago already, and I was actually always well known as a pioneer of 3D printing and well established in the additive manufacturing space. And I actually took over the company 1 year ago. We are market leader for metal solutions and polymer solutions in the space of additive manufacturing. And I'm very excited to be here today.
Great, well, thanks for joining us. And Rick, Desktop Metal, you may have a slightly fewer less years in AM, but nonetheless your company's made a big impact and you're already planning an IPO. How's that going?
It's going very good. Yeah, we're scheduled for early December. So about December 8th, between the 8th and the 10th is the plan.
Excellent. And we'll get into a bit more about the different technologies your companies offer in a moment. And thank you very much for joining us. I'm sure the audience is going to have a lot of questions. But first, I've got a question for the viewers. You'll see a poll popping up on your screen. And we'd like to know which of these areas, automation, sustainability, or on-demand manufacturing, do you, as a viewer, as probably an AM practitioner or someone who's interested in the space, consider to be the most important trend in additive manufacturing? So I'll let that poll run for a bit and we're going to come back to that in a moment. But for now, let's get on with our first section, which is going to be around the market trends. Now, obviously, 2020 has been really a year like no other. And the effects of a pandemic, which is still ongoing, have been felt dramatically across the world. Now, there's a case to be made here that the pandemic has accelerated or crystallized several of the trends that have been active in additive manufacturing for some time. And here I'm talking about the ideas of stock digitization or establishing protocols for serial production, also accelerating the need for certification as well. But I'd really like to get into a little bit and just hear from you, Marie and Rick, what your thoughts are about the trends we're seeing in the market and how how the current crisis has really influenced your strategy this year. So Marie, perhaps you could tell us a little bit about that, please.
Of course, I'm more than happy to. So actually, what we saw in the last year, especially with the whole COVID pandemic that we all had to experience, is this theme of distributed manufacturing actually became very big. I think it was always a theoretical topic. A lot of people that got involved in additive manufacturing field were very well aware of, and much more companies also, of course, investigated that area. But I think, we saw this in our networks, and I think everyone in the additive space can speak about this, that especially with the pandemic, we were challenged with the last month. We really could prove the potential this technology has, especially when it comes to more flexible supply chains, when it comes to more resilient supply chains, and really looking more into localized production. So the additive manufacturing space is offering a lot of possibilities for digitalization, and we also see that a lot of many more companies right now look much more into digitalization than they did before, because they really became aware with COVID that that's something they all need to invest in. Mm-hmm. So we also see like a huge potential and also now market trend here for organizations and big OEMs and supply chains to look in more localized and secure supply chains.
Okay, and other than what else about 2020 have you sort of seen really crystallizing some of the activity of like the past 5 or 10 years in AM?
So actually, we also were kind of seeing that the whole area of new space was picking up a lot. So we all know that aerospace is kind of like a home turf for the additive field, but especially now with all the tourist stuff flying around and all the business people stuff flying around, of course, the whole aerospace area got a little bit of decline in demand, and we were really excited that actually this area of new space is actually picking up a lot. And so we're talking about like all the satellites that need to go to the universe and all the digitalization efforts we see here and the data connections we need to offer to the world to really be able to roll out this kind of concept. And there we see a tremendous amount of organizations, especially startups, look into that field. We also founded actually a company called AMCM, so AM Additive Manufacturing Customized Solutions, customized machines, who could also very specifically invest in that area, and they actually take standardized products from us and they customize it for specific industries. And here they realized actually also that we have bigger build frames to really realize some applications for the new space area, and that's what we're really excited about. And actually one last topic I wanted to mention is that also the whole topic of responsible manufacturing or sustainability that AM can offer is getting more and more looked at. I think our whole generation, and I can account myself to that as I'm quite young myself still, is more and more interested in really how can we connect like the performance goals that we have when we look financially at our improvements, also with the benefits and the impact we have in an ecological and social way. And I'm 100% convinced that additive has a lot to offer there. I'm also convinced that we are more at the start and not at the at the end. But I will have, I think, some questions towards that later. So, but these are kind of like asking me about the market trends. That's a little bit what I would summarize here. Yeah,
there's definitely some very big topics, and I think we're going to get more into sustainability and responsible manufacturing a bit later on. But Rick, we've spoken before the show a bit about what you're describing as additive 2.0, which is the desktop metal sort of take on the trends that are going. Perhaps you can tell us a bit more about that, please.
Absolutely. Look, I was a heavy user of additive technology in the past And before we started Desktop Metal, and an investor in the space, and in both the engineering software aspects. We backed some of the major companies in the space, as well as investing in the parts business. We were the original backers of Protolabs, which is a major user of technology today, and other companies in this area like Onshape, which we sold to PTC last year. I would say that my point of view of the space is that it's about to go into an inflection. So if I put up this slide just to show you, at the beginning of the early days of additive, you had machines that could produce shapes, but they didn't really have the material properties. And then we went into a phase that where the industry grew quite a bit, where we call additive 1.0, where you could actually get the material properties, but you couldn't, and you could produce the shapes, but you didn't really hit the cost targets to really make it a mass market business. And the biggest issue when you talk to a Fortune 500 company about additive is, or a small shop, is that cost is a major impediment to really making this a mass market industry. We make $12 trillion worth of goods a year, and less than 0.1% is made with additive. And so the question I have is, how do we get that to 1%, or eventually within our lifetime 3 to 5%? And that's really by going to area-wide processes and really removing the cost out of the materials. And so I'm excited. We're entering into this new phase of the industry where you have end-use part production. So you make actual parts that go in products. And you don't have to just rely on, medical and aerospace as the only places where people can afford these components, but you can actually mass produce them at scale, where even simple things that used to be made with machining or presence center or other techniques, you can actually now produce in volume in 3D printing. And if you look to this next page, you still get all the benefits of additive through these processes, right? I mean, we've used additive to do physics-based manufacturing, to mass customize, to consolidate assemblies, to re-engineer your supply chains, to have no inventory. All of these things still make sense, but now you can actually go to market at scale with a cost structure that's cheaper than machining and cheaper than casting for conventional parts. And so that's what our company is focused on, is being able to make parts out of low-cost raw materials at very, very high throughput, where you compete with machining and casting and conventional methods. I was talking to a good friend of mine, Sanjay Mortimer, who started E3D. Mm-hmm. Many of the folks here, they've won many awards from 3DP in the past, and other folks.
Every year they win.
Yeah, and they're in the mass market, right? They make components that are used in mass market printers. And we were talking about a particular gear that was difficult to make, and when they machine it, it's 86 cents. When they when you look at making that part with our process, if you took a shop system, which is a mass market product starting in the $160,000 ish range for the printer, but we can give you a full turnkey solution. You can make that part, instead of for 86 cents, you can make it for 50 cents. And if you did it on a production system, you can make it for 16 cents. So, here we are with now all of these benefits that you're seeing on this page, but also with the cost as a game-changing solution. And so that has been the mission that we've tackled. And so we're really going after the mass market of printing with very cost-effective solutions that we think can produce parts with less expensive raw materials, and then eventually scale that to a mass market.
Okay, excellent. Well, some big themes there, and I think we'll take a bit of a look at the poll and see how that's gone, and see what the viewers think they consider the most important trends. And well, we've got automation has come out on top, with 46% of people saying that's the most important trend in additive. That's followed by sustainability at 30% and on-demand at 23%. So is that surprising for you, Marie?
No, not at all. So I think that people always feel that everything needs to be automated, that sometimes might not be cost efficient to do so yet. So I don't think it's surprising, as we live in, like, a digital world, and we want to digitalize everything, and we have this idea of this smart factories where everything is automated and all the robots are running around. And that will be an end stage where we will be heading towards. And of course, we have partners working on solutions and shared model systems here. But from my point of view, I think the automation will still take some time. And I think the industrialization of the technology is a more important part to do first.
Yeah. And Rick, would you have expected those kind of results, or would you have expected another trend to be in there as well, possibly?
Yeah, I think that the most interesting part about, I think this is right on. The most important part of this poll is that on demand, which is what you would consider prototyping, is last. And, this is, there are lots of prototyping solutions today. So it is no longer, that was the original landing spot for 3D printing 20 years ago, 30 years ago. But today we've gone from prototyping into producing mass production of end-use parts. And so you look at automation, like Marie said, because people are focused on cost. And so I think the other aspect that's unique, you don't see it on this poll, but the reality is we don't print products, we print parts. And it's going to be, we have such a long road to innovate in this industry. We got 30, 40 years of innovation. We can go from printing, we go from prototyping to parts, and then eventually from parts to products. One day we'll be printing things that are a lot more sophisticated than what we do today, and you'll have multiple materials in it, and you'll have the ability to make a fully functional product. And so we have a lot of work to do in the software and in the printing processes. There's going to be a lot of innovation in the long run.
Well, the viewers, I think maybe they're still sort of recovering from a very large feast yesterday, because everyone's quite quiet at the moment in the chat. But if you have any questions for us, please do send them across. Now, Marie, I've got a question for you. EOS have talked a lot about distributed production in the past. Maybe you could tell us about some of the challenges and the opportunities and the solution that EOS provides there, please.
Of course. So I think if you, first of all, if you look at distributed production, then it's about identify the right applications. So what are the applications that really make sense to produce decentralized? And despite the fact that now with COVID and the whole pandemic, a lot more organizations realize that they need to have more flexible supply chains. I think looking at spare parts and what they can contribute to the industry, I think is a very good example. To illustrate the distributed production and manufacturing theme. So what we see here is actually, and then for example, we worked with Evobus, that's a company of Daimler in the automotive area, and they're producing buses actually, and we worked with them on identifying parts that they can use for spare part printing, and we identified actually more than 3,000 that would have the criteria to do. They picked actually 35, and they are printing them now, and they're even starting serial production with that now. So what we see here, so I think this is illustrating this distributed production. You produce it where you need it and when you need it, and you don't have inventory stored that costs you a lot of money, or you have all your supply chains where you have to have contracting to be able to get the part in the right time when you need it. So I think on demand, and Rick, that I agree with you that this was also fitting to the prototype world. I think on demand also fits to the serial production world, but more in the customization or kind of targeted customized production kind of sense. And I think that's where the world will be moving anyhow. And we all need to move because we only have a specific amount of resources and we cannot waste everything. So I think it's just a matter of time until everyone will understand that that's the future.
Well, indeed, and I think linked into that, a question has come in from Frederick DeWitt, who says, what do you think of the business model of designing in one part of the world and printing in another part close to your customer? And you touched on that a little bit there, but Rick, perhaps you could say a bit.
I think that's a great model that will evolve over time. In particular, you don't have to pay for tariffs. You don't have to, you could mass customize to a local environment. You don't have to ship things all over the world in boats, and your tonnage, which is the ratio of space to of air to like actual products in a container, can go up dramatically. So it is a more environmentally friendly way to do things, and a lot of these business models make a lot of sense. You have companies like John Deere and Caterpillar that today inventory millions of parts, and they have a brand promise for their customers to have to essentially take care of a mining piece of equipment or a tractor that was made 20 years ago or 30 years ago, and that is a model where in the past you would produce, when you had tooling, you would produce a slightly larger run of a particular good when you made it, and then you would inventory the spare parts. And now, if you're left with no spare parts, we have one customer, John Zink, that makes tankers. They make the fuel atomizers for the combustion system in the tankers, and they have some really complex fuel nozzles from like the 1960s. They don't have the drawings anymore, and then somebody shows up with like the broken part, and somebody's supposed to make this thing that was a casting where there used to be tooling, and they got to get this machine up and running again. And so we have applications like that where you have to just essentially rebuild it, but also like the ones that I mentioned earlier that basically will free up a lot of cash flow and make it more efficient to take care particularly of industrial equipment. And we have applications also in terms of enabling higher performance, because the harder the material, the harder it is to machine it, which would be the alternative approach. But with 3D printing, you actually have freedom to work with very high performance materials that and shape complex parts. So do it more environmentally friendly approach to doing it.
Let's get into some of the actual applications now, and some of the business cases. And we've been talking a little bit about this before we went live. And Rick, in particular, you were talking about how you see Desktop Metal really unbundling the powder metallurgy industry. Perhaps you could tell me some more about that, because that's a fascinating topic.
Yeah, so powder metallurgy is a route that can be used to make. There's two ways to make a metal part. One, you can either sinter it, and there are many companies that do that, and that's when you expose a metal to a temperature close to the melting point, but not all the way molten. And when you do that, you could use, then the powder consolidates, it shrinks a little bit, and then you end up with a fully dense solid metal part. And you could have a reducing atmosphere, so you could have less expensive raw materials because the oxygen can be reduced, which is something that's more difficult to do in other methods of 3D printing. So the reason that's an attractive proposition for an additive manufacturing place, powder metallurgy can be an incredibly efficient and low-cost way of making parts. But before you could make that work, you needed to make sintering and simulation easy to use and mass market, because powder metallurgy in itself as a process requires extreme know-how to be successful. You need PhDs and metallurgists on staff. The equipment for sintering is, things that take 6 to 9 months when you order, and you need a special facility. And then once you start to do it, you need to have quite a bit of know-how to end up with net shape components. And so our challenge was, could we take a process that lends itself to like a centralized manufacturing process, and then fully automate that type of manufacturing, design easy to use systems that are on wheels and fit through a door, that could be installed by a global chain, supply chain of channel partners, where literally you roll them in and you plug them in and you're making parts, and you have the software and simulation to enable first part success with those customers, where they're not, instead of having a black box where you put in a part, it comes out and you don't get the shape that you wanted, and it takes you 6 months to be successful. we wanted something where you put in a part, you get out a part, and you're successful out of the gate, and you could work with microstructures that are well understood, where it's homogeneous. You could get bainite or pearlite ferrite or martensitic, and you could tune all that stuff. And so that was kind of the vision for that. If I can put up one slide to explain it better, maybe this will do it. Let me just so really it's the ability. Binder jetting, for example, as one technique to mass produce products existed for a long time, but the systems to do that weren't fast enough and were too expensive, and they weren't area-wide processes. Whereas you print the whole layer at once, you essentially had sequential process where you spread powder, then you scan a print head over the bed, and then you had to dry the whole layer. And so it's a slow process. And so we made that super fast, where we make an entire layer in 3 seconds, for example, with our production system. And that includes spreading of powder, printing of the layer, everything that's required for a single layer in 3 seconds. And then it's bidirectional, so you're getting it at very high throughput. And then we developed sintering technology. It was easy to use and fully automated. And then the sintering simulation with multiphysics simulation that enabled you to get first part success. So it's really that combination. Without that, it's it didn't make sense to deploy this on a mass market basis. So now we've got these solutions, and they're quite cost effective, and then they scale without adding cost every few years, because the core technology that enables you to increase throughput is inkjet, and inkjet doubles throughput every 18 to 24 months. So we get a scaling law attached to a process, and that gives you the ability to, over the next decade, have technology that's going to continue to get more and more cost effective by essentially putting in new process. So that's been our focus for the past 5 years, with a lot of investment to fully automate that and to make it real. I'm most excited not about the niche, high-end applications. I'm really excited about mass market, high volume production of metal parts. We've got companies that are doing the little metal parts that go in a Louis Vuitton bag. They're used to be made with stamping, and now you can make them at scale with less expensive, but now you have all the environmental benefits of additive and with more complex shapes. So it's opening up the market to a broader audience.
I mean, you mentioned there mass market, high volume. With that, I suppose, goes hand in hand with reducing the cost per part. How do you accomplish that?
Yeah, I mean, we have a process that produces parts under $50 a kilogram, finished part, and that includes material, labor, rent, consumables, depreciation, everything on the mass production systems. And I would say you achieve it by essentially having a process that can use low-cost raw materials, having very, very high throughput. We make machines that make 12 liters of parts per hour, 12,000 cc's, and that's with like one print engine. And every 2 years, we could continue to improve the productivity of those systems. So you'll see a durable compounding effect over time, I expect. It doesn't do everything, so you can't do big, really large parts. Is very difficult to do. It's not designed to do that. So, but if you think of something that's the size of a basketball or smaller, it's a really good technology for that. And for things that are large, there are many technologies that are better suited. But if you something this size or smaller, we can do really good things.
And Marie, you have some of those other technologies, I know. So maybe we can take a look and see sort of what EOS equipment has been used for. Do you have some examples of applications there, please?
Yeah, of course. Let me just go to the slide where you see them all. So I just brought a number of applications to you to show a little bit. I was switching my video so you can see all the applications better. So you can see that we're kind of like in almost every industry. I brought some examples. So the upper left and the down right, you see an insole that we can actually mass customize, and there we really look at the whole potential that additive brings with the customization of the insole, so it really fits to the feet, and that's integrated. Actually, we work together with Atrex on that, the partner of ours who have like a foot scanning technology, and then they will be sold at the retail store. So you also see that there's business model innovation going on. Then we have the helmet on the down right, where we already actually do on-demand production and also localized, decentralized production. And here you can also see that, of course, with the application, you can fit this better to your head, and by there can reduce the danger that occurs when you fall, and then how the pressure will be released to the brain. And I also brought some nasal swabs that you can see here that actually are right now in Spain together with two partners, and in the US are actually produced over 30,000 a day actually. So that's already quite a big number in the additive world. And then I brought two other things that I think are very exciting in the medical field, the anti-scattercrits that you can see there, where we have already a machine park running 24/7 and they are produced reliably. I think when we look at applications, it's always the most important that can you produce reliably. And that's something we achieved here together with our partner Danley that we're really proud of. And there it was very important actually to have it for mass production of components, but also have very thin walls that were required for applications that go in CT systems. So that was the challenge here. The additive fits perfectly for that. And actually then there's also another example, and it's a heat exchanger that you can see there. And I'm really excited about this, as well as here we could really have a smaller part actually and a less heavy part. And with that, we're able to reduce the cost and also the individual chip thermal footprint massively. And then there are some other applications in the like for Ariane, like the rocket engine, or also in the automotive area. And to all of them, actually, the same thing accounts. So I will not go totally into details, but I'm happy about questions if someone wants to know more.
Excellent, thank you. And yeah, speaking of questions, we now have a lot of questions coming in here. One from Colin Cools, which is a very optimistic question. He asked when, not if, but when do you think AM will replace all manufacturing? In 5 years or in 20 years?
I would say Colin is fantastic. Sorry, Marie, go ahead.
Sorry, you go first. You're longer in the industry. Then I take my more junior view on that.
No. Please, please.
Okay. So I just wanted to say I don't think additive will fully ever replace conventional manufacturing. I think it's about the integration of additive with conventional in the whole digital world. And so Rick, I think he also pointed to that already, that there are different technologies for different applications, and it's not that every technology can do everything. So I think also in the additive field, we learn more and more now, and I think we will see that over the next years as well, that companies will more specify into industries and specific application fields. And with this, we will see more additive, but I don't think that it will be only additive. That will be there some, but maybe Rick, you can specify that a little bit, or you have more proof points for that.
Well, my point of view is that as humans, we tend to overestimate the short term and underestimate the long term. And if you ask somebody that had a Palm Pilot, that then had maybe a previous device before, and then all of a sudden you've got an iPhone and it really takes off. So I would say that you know, you probably remember the cover where Nokia was seen as invincible, a $1 billion company right before the iPhone comes out, right? So I'd say that disruption is always happening bottoms up, and the reality is, I do think. Well, by the way, Colin is one of our customers. It's really exciting to see him here on the call. So hi, Colin. It's fantastic technologists from Canada. They do all sorts of automotive components that are high volume, and I would say 20 years from now, so maybe we get to 1% of penetration by 10 years, by the end of this decade, but then it's going to be much faster beyond there, and you can get to 5 or 10% or double digit. I'm sure that in my life we will see double digit of the way that we make parts, and there's incredible amount of innovation on all the core processes for additive, whether it's resin-based printing. There's some really incredible technology with high temperature printing using resins, and ability to now for the first time achieve material properties that you did in toughness and in terms of elongation of break, and UL94 V0 rated polymers that you just, materials that could basically perform like PEI or PEEK type performance, but on that environment, or with elastomers. Incredible innovation happening, and my point being that all of the processes are moving forward, or several of them are moving forward with incredible speed as we start to go into end-use part production. So I think it's a function of more people doing research and in this field, and I do think we're going to see in my lifetime double-digit penetration of additive as a way to make parts. We'll spend the next 10 or 15 years working on a single component, and I think eventually we'll be working on multi-material printing approaches down the road at scale.
I'd love to spend more time talking about that, because that's a very interesting area, but we do have a limit on the time today. So let's get into our next section, which is where we're going to look at sustainability, a very sort of popular and important topic as well. And on that note, I'm going to, again, I'll turn it back to the viewers momentarily, just to ask the question here. Well, is additive manufacturing a sustainable technology? Let us know what you think, and we'll come back to the results for that in a bit. And I don't know if either of you saw the Materialize World Summit. This time it was online a few weeks back, just after Formnext. So I can understand if you weren't online again after a week spent at a virtual trade show. But I think, as always, Fried van Kraan at Materialize, he made some really interesting points about sustainability, and in particular some work they've done with BASF on a life cycle analysis, i.e. looking at the impact of manufacturing anything throughout the value chain, from sourcing the material to using that, to getting it to the customer, to disposing of it. And this was quite a lengthy piece of work they conducted, and I think they focused on 3D printed insoles, and in particular producing at a scale of 1 million units. Now, the research there, as expectedly, came out that if you're going to use standard AM techniques to make 1 million identical parts, this isn't necessarily the best approach. But it did really highlight the need for more work to go into working out what are the opportunities where AM can be sustainable. And I know, Marie, ever since you've started leading EOS as CEO, you've talked a lot about sustainability. Perhaps you could tell us how you define that and how it's characterized at EOS, please.
Yeah, sure. I'm happy to do so. So it's good that you mentioned it right at the beginning. I feel very strongly about sustainability, and actually, I think it's also funny to share that that was even like the idea I had with my dad. I said, like, I will only take over if you let me do the sustainability piece, because I was so convinced that this is something we can do with this technology, and actually to really leverage all the potentials that we have. So maybe before I go into a little bit of details where I think we should start to work on and what additives can bring, and I think all the concepts were discussed already a lot of times, I just wanted to quickly share with you. I showed already this like a responsible manufacturing theme with our hummingbird. That's our like purpose, our logo for that, and branding, and the whole company is actually working towards this purpose. And with this, we actually also ask ourselves, hey, what does responsible manufacturing actually mean for us? Like, what do we mean with this? What do we want to do? And what kind of strategic priorities we also want to roll out in the company to work more towards that vision of responsible manufacturing. And we actually define 3 areas, so they're quite common. I think they're not totally new for US, but I think it's always good to kind of like specify what you mean and also look in specific areas. So first of all, of course, we look in people. So how do we treat our customers? How do we treat our employees? How do we treat our consumers? All of that. Then we look at the planet. So how can we really make sure that we respect the limitations of our planet? And I think all this digital designs that we can do, like the bionic designs that we can realize, the resource efficiency we can generate through that, are already signs that there is a potential that we can leverage much further. And then it's also, of course, about performance and responsible business practices. So not only making sure that our systems run on a specific carbon footprint and that we meet our carbon footprint goals ourselves, but also making sure that we adapt our supply chain towards that. And so really like, we really mean this, you know? And I think what is really important now to start at is looking more into material consumption. And we all know that a lot of companies want customers to use a lot of material because that's how they can earn a lot of money. So I think in the end, it's really about like, of course, you can always have high performance materials and you can also charge for that, but really making sure that material consumption gets less and we don't create so much waste, especially in the metal area here. And then, of course, on the polymer side, biodegradable materials, I think, are a big step, and also BASF and other companies are working on that, and they're great partners in this. And then I think, of course, we all need to better understand how this like smart factories should operate and how we can optimize the carbon footprint there. And then, of course, looking really, and I think there are a lot of education still has to happen in the market. How can you really use the technology to leverage it in the best way possible and to reach also your sustainability goals? And the more and more OEMs ask us about that as well. So it's not only kind of like an idealistic idea that we just had. It kind of fits my value set, but it's also something where especially automotive area, for example, looks a lot into. And they also kind of challenge themselves to find solutions here. So we also look into entering new industries like the e-mobility area or efficient cooling and energy. So there's a lot of potential. What we actually did is bringing in a head of sustainability. He was working for DHL before, so he was quite successful in introducing some sustainability goals there. And with him, we actually will make sure, together with our team, to really define the right carbon footprint goals, and to really start to measure data. Because what we realized is that there's very few data. There's a lot of assumptions, there's a lot of opinion, marketing, but there's a lot of proof, not a lot of proof points. What does this really mean? And I think that's something also from material side or other now associations that were built to actually look into that. They all have the same voice in that. We want to understand it better. We want to get more data, and based on the data, improve. And so that's our approach and our take on that. And we're really looking forward to work actually with everyone on this, because that's not a piece a company is doing. That's a piece that a whole industry and sector needs to do actually. And I think with this, we really have an enormous, exciting path for AM in front of us, because also on the political side and all the governments, they all look very in detail in this technology right now. We just have to hand them over the proof points and show them that we can even leverage this much further.
And for sure, Rick, you've had pretty substantial experience actually in the green technologies markets in your sort of previous life, really working in the battery world. So I'm really interested to hear your sort of take on this and where AM is applicable to what are commonly termed green technologies.
Yeah, so we were referring to. I did spend from 2010 to from 2000 to 2010 the commercializing the first high power lithium ion batteries that were cobalt free, which is now a mass market technology. But at the time we innovated there, and we made products for pretty much all the major automakers, including the bus maker that Marie mentioned earlier, that's owned by Daimler. So all the buses in New York City that are hybrid run on our systems, and we spent a whole. It feels like a different life, having been in electric mobility before I came into the additive space, and I'd say that we did have a sustainable angle when we chose to develop our company. The reality is manufacturing processes have scrap and waste that are associated with it, or pollution, like all manufacturing that's associated with it. And so if you look at casting, it is the process with very difficult to permit today in the Western world for a high volume casting facility. A lot of it has moved to India or China, and it's still a major process to mass produce parts. You've got limited geometries and other constraints. If you look at machining is how we make a lot of components, particularly in aerospace and other markets. The reality is that if you're machining aluminum, you could recycle the aluminum chips, but if you go to any high-end alloy, if you're machining titanium, if you're machining inconels, etc., you have an incredible amount of scrap, and that's because the materials like titanium will absorb oxygen when you melt them, etc. So reprocessing them is very expensive, and as a result, you're if you're familiar with the aerospace term of buy to flight ratio, you end up with you start with a big billet and you throw everything away. It makes no sense, and so additive has had a major impact in making it more efficient. The particular approach that we're focused on, where you're printing at room temperature instead of at high temperature, enables you to recycle all the powder that doesn't make it to a part, and that has some particular benefits in terms of having less waste, and also you end up with a thermal process that's highly insulated, where you do many parts at once, so it's very energy efficient in terms of kilowatt hours per part. But all additive in general, I would consider it a greener process than something like casting or machining, or a way that you made stuff for. Injection molding is a relatively good process. You don't have an incredible amount of weight. You could reuse a lot of the materials, but it's certainly there are huge opportunities to lightweight parts, like Marie mentioned. Use bionic designs, and that has secondary benefits if you're going to be in a transportation application, and also. Yeah, so it's definitely an area where additive can have a major contribution to society.
Zane Druby asks how much additive manufacturing is involved in the field of renewable energy, and do you think there'll be more of this in the future? So I think that ties into this. Who'd like to take that one?
Marie, do you want to take this one first?
Oh, sorry. I thought Rick, you asked Rick. Sorry, I misunderstood. So, of course, with our innovation team, we look into these topics, and there are projects that we're exploring. Of course, that's very early stage, but definitely there could be options. But nothing specific I'm allowed to talk about. Sorry.
Okay.
I would say that in renewable energy, additive's going to have a major impact in tooling for wind, and in making large parts in that segment. In solar, I'm not sure how it affects solar. I don't think we're going to be 3D printing solar cells anytime soon. In terms of area that I'm really excited about is the ability to print trash. What I mean by printing trash is taking a waste byproduct and then converting it to an end-use part. And your raw material is now very cheap. And so if you can find a way to take a conventional additive process and take a waste stream and make end-use components that are high quality out of that, I think that that's going to be an interesting route. And so that requires new atomization technology, for example, or in the case of metal. But we do have we actually have an effort in that segment in a non-metal application where we can print components. I'm not ready to discuss it. We're not ready to discuss it yet, but I think that in the next decade or next actually year or two, printing end-use parts at scale with raw materials that would have been waste is actually an exciting field.
Well, keep us posted on that. And the results of the poll have come in, and we may have a slightly biased audience here, but 3/4 of the viewers today say that yes, additive is a sustainable technology. And I think we've touched on some areas where that can be the case. Now we're running out of time, so I want to get into this before we do run out of time, which is what's coming next. What's the vision for the future? And certainly, I know, Marie, at EOS, you have your Additive Minds division there, and there you help for your customers identify new use cases. Perhaps you can tell us some more about that, please.
Yes, of course, I'm happy to. So, actually, we created that team. We founded it 4 to 5 years already ago, as we kind of realized that we need to educate our customers and take them with us to really show the capabilities of the technology, to make sure that the right application engineering capabilities are there, and to really make them understand, to identify together with them the parts that are actually really useful for them to 3D print and to use additive manufacturing technology for, and where also, of course, the specific benefits of our technology lay in and where it doesn't. And so actually what we were producing, and here in the slide you see it a little bit and as an overview, is taking our customers really from like the digital thread to the digital twin to digital inventory as like one example, where you then really can go along the whole digital value chain and kind of really specify, okay, what are the benefits of AM and what can our technology contribute at every step that is important here. So from freedom of design to speed to market, what I think is like the speed to market topic is popping up a lot. So where you see that companies want to innovate more and they want to get faster out to the consumer, test it, and then reiterate, and not having like a huge and long production cycle set up before. So the whole optimized production topic, then secure supply chains. We touched that already when it came now to COVID and the flexibility of supply chains, and then really also like a controlled phase out. And so what we learned is actually that it's really important for a specific customer group of ours. Of course, there are some who just want to have the technology and they know how to use it, and then it's very critical what they do, and they also don't want to get accompanied by that. But there's like a massive amount of companies that actually really want to understand how they can use this technology, and that's what our Additive Mind team is there to really identify the application, to design the application together, and to really leverage the application. So I touched it before, so I will not stop this anymore, but I think really the future will be to integrate additive into the digital value chain and the smart factories. If they're right now still big, and I think they will get smaller, and with that we will elaborate much more potential of our technology over the next years. And so I think that's to really become digital champions, to really master this digitalization. I think that will be a strategic benefit that every company will have in the additive field. Excellent.
Okay, thanks for sharing your perspective there. Rick, what's the desktop metal sort of perspective? What's coming up, do you think, in terms of how your solutions really begin to scale and how you start to reach that those sort of those goals of mass market, high volume?
Yeah, so I think additive as a technology wins when it becomes mass market, and we no longer have to do gymnastics and to just figure out where the technology fits. And part of that is to make it cost effective, but another big part is to enable materials that give you performance that you didn't have before. Obviously, you know, as long as it's not unobtainium and incredibly expensive. But on the medical side, you're going to see incredible innovation on the material science side, I think, over the next decade, and great adoption of the technology by enabling you to print new types of materials that enable new applications. And then even in the mechanical world, you know, I think interiors in automotive is a major segment where it's a cost-effective process for many parts, and it's very much about our view of it is let's design broad application horizontal platforms that can be mass produced efficiently, and then can then enable many different types of markets, as opposed to have a niche where you start and to do that in a cost-effective way, where the cost per part is you know, competitive with conventional manufacturing, as opposed to competitive with some business model. You have, if you're not competitive with what people are doing today, without having to like completely change everything you're doing, then it's going to remain a niche. And so we're trying to figure out how can we turn this into something that could be 100 times bigger, and the only way is to really kind of reach the cost and speed and material properties qualities that you have in other processes.
Thank you. So just to wrap up, so we're really close to the end now. If you maybe could briefly, Marie, could you tell us maybe what you think the long-term lessons from 2020 for the additive manufacturing sector will be?
Of course. So I think the long-term lesson will be that we need more resilient supply chains, and that additive can contribute to that. I repeated that like a lot of times already. So but I will do that continuously because I truly believe in it. And I think from, you know, if you look at in the longer run, also what will be really important from my point of view to really look into like 3 topics. It's digitization, it's industrialization, and it's sustainability. In the end, the 3 things have to come together to really leverage the best potential of these technologies. And that's not only accountable for EOS. I think that is referring to every player in the industry too. So, and also not only like looking at, of course, everyone has like their market trends and everyone has their market goals and revenue goals, but in the end, really also understanding better where can we co-create, where can we collaborate, where can we bring this industry further together, how can we make sure that the pie is getting bigger, that we all are sharing. And I think that should be the goal of all of us.
Great. And Rick, what are your thoughts here, just to wrap up?
I mean, I think that for folks that are new to the industry, this is a fantastic place to be at, because we have a long arc of innovation. It's like in The Graduate, that movie where they whispered, like, get into plastics back in the 1960s. This is definitely at the right inflection point where the next 20 years, we're going to see broad penetration in small companies, medium-sized companies, and very large companies to mass produce with this class of technology and make end-use parts and components. And so I think that you go back 20 years ago, very few people, even in university, would have used a 3D printer, whereas today they're commonplace. And so the next generation of engineers are really being primed to leverage this class of technology. And I think you know, we're going to see incredible amount of innovation on top of, in particular, because the core processes are off patent, and so that enables a lot of people to invent on top of that and create new modes of manufacturing parts, and then build IP on top of that. So I think that it's you know, there's an economist in your neck of the woods in London Carlotta Paris that studies Gilded Ages, and she has a great book on this area where, you know, the kind of first 20, 30 years, you've got an installation phase, and then you've got the next 20, 30 years of like a deployment phase. There's usually like a crash in between, which is what I think happened from 2014 through maybe 2 years ago. I'd say that we're going to experience some fun times in the next decade.
Fun times ahead, I hope. And I'm glad you mentioned The Graduate, because that was what the illustration for my very first article was about, additive manufacturing, way back in the mists of time somewhere. But anyway, thank you so much for your time. Thank you to everybody who asked questions. And if we didn't have a chance to get to them, there is actually now a LinkedIn group, which I will share the link to in the chat, where these conversations can continue with the advantage that LinkedIn is open 24 hours a day, whereas it's Friday, so I'm sure we're all off to do something else right now.
I love it.
Speaking of Fridays, the 3-Day Friday talk show will return on a Thursday next month. So we're going to be back on the 17th of December, when the topic will be building an AM agile organization. And joining me for that conversation will be Gil Lavey from 3D Alliances and John Barnes from Barnes Global Advisors. There are two names I'm sure many are familiar with. But Rick, Marie, thank you very much again for your time, and thank you for your mind.
Thank you. All right, and stay safe.
Thanksgiving.
Look forward to seeing you at a trade show at some point next year, I hope. Bye for now.
Take care.
Thank you.